um, figured out.
Okay.
Um, so I pulled up the document that it has, and it gives us a few possible topics that we can do. Um, so I don't know if you want to read through some of those and kind of see what interests you. Some that I thought were interesting. Um, is um, there was one about Starburst.
Mm-hmm.
Are they greater than the others? Um, um, what else I thought was does one brand of popcorn have higher popping ratio? But that one would be kind of hard to do. Um, who returns their shopping carts more, men or women?
Mm-hmm. Go to the local cemetery and compare the number and size of male and female tombstones.
That one's weird.
A little morbid.
I know. I'm just reading.
Do you want to do the Starburst one?
That sounds cool.
I think that would be an easy one to do. Easier. So it's something that like everyone can relate to.
Yeah.
Or they should be able to relate to.
Okay, on the top it says, list the names of your group members. Each person listed here is responsible for this project, both academically and legally.
I know. I saw that. I was like, whoa.
What
Like
if I
I'm-
don't want to?
I know. I feel like I'm signing a contract.
Some things I don't even know how you test. Like, do Oreo double stuffed cookies contain twice as much filling as regular? Would you like scrape it out and then measure it?
Yeah. So I think.
And then
But
like,
then how would you make sure that is correct?
yeah, some of them are kind of weird.
My husband did the Starburst one when he was taking this class.
Your husband did?
Yeah.
Well, perfect. That's what we're doing. He can guide us then.
It's super easy. I think, never mind, it's recorded. I can't say what we did. No. The results weren't exact, but we still got an A.
What do you say?
He said the results weren't exact, but they still got an A.
Good.
We like A's.
So what I'm thinking for the research question is we can see like in each pack we can get like, I don't know, 10 or 15 of those small little packs. Sorry, there's a storm blowing through.
Like stick ones, like the bar ones.
Yeah, like the little bars, well, the bar ones. And we can count like how many of like each color is in there. I mean, of one color.
That'd be good.
Like, let's see how many of like the yellows are in each pack. I'm guessing that they would all be the same, but
I don't think they are. Sometimes you don't get very many pinks.
I think pinks get gypped.
No, or sometimes you get those little packs that have like 2 yellows.
Oh, those are the worst.
Yeah, or orange. Yuck.
Okay. I don't like Starburst, but I'll only, if I have to eat them, I'll only eat the red ones.
Yeah, I like red or pink.
Okay, so what do you guys think it should be the research question?
I would say, I figure out how to word it.
Okay, can I say that ever since we moved to North Dakota, it's like rained or stormed every single day.
Really?
Really?
Yes, and there are always like tornado watches, and they're like, oh, severe thunderstorm warning.
That sucks.
That's how it was when I lived in Chicago. Like every single day.
Yeah, it scared me yesterday because the alert system came on the radio, and it was like, severe thunderstorm warning, take cover, golf ball size hail. And so I called my husband and I was like, get your butt back from work now.
That would be scary.
Yeah. Not
I would
enjoyable.
not like that.
No. Like in Idaho, you never get those. You never get thunderstorms.
I like
It rained a little
thunderstorms.
bit. Yeah, we like thunderstorms.
I don't like wind unless it has wind.
Yeah.
But it probably would get old having a storm every single day.
Yeah.
So, I'm trying to figure out how to word the question. What do we say? So, what color were we gonna do?
Do you want to do like random color?
What
Right.
color?
One of the unpopular ones, like yellow or orange.
Yeah, that's what I was kind of wondering.
And we can say that we're testing to see if there are fewer of those of like yellow in the pack than the other colors.
I think there's always more though.
So the list of possible topics is the percentage of whatever color greater than the other. So should we say
We are testing to see if there are more yellows in a pack of Starburst than any other.
is the percentage of yellows greater?
Yeah.
All right, we choose.
Okay.
Do you want to do just the original Starburst, or do you want to pick?
I think it'll be easier to test the original
Yeah, that's
because more
true.
people are familiar with it.
That's true.
Unless we weren't taking like a survey, unless we were just doing like our own thing.
That's what we're
Yeah.
doing.
Oh, okay. Then yeah.
Let's just leave it how it is.
We'll specifically say original Starburst then.
So the population would be the original Starburst.
Yeah.
And then what are your null and alternative hypotheses? So the null would be that the percentage of yellow starburst is the same as the other colors in each pack, and then the alternative would be that it's greater, right?
Yep. Population of original starters.
Wait, what would be the null?
That they're the same.
The alternative.
That it's greater.
Okay, so should we say that we do simple random sampling? Because I mean, we're not going to see what's in the pack. We just go and take some.
Yeah.
Like I could go by 5, and you guys can go by 5, and then we can count up our individual packs and then come together with it.
Yeah.
So do you think we should have a bigger
Simple
number?
random sampling. So number 5, we will take 10 packs of Starburst, original Starburst. And determine how many of each color, right?
Mm-hmm.
Would it be stratified sampling though? It says is when items to be sampled are organized into groups of homogeneous or similar items. Then a simple random sample is drawn from each of these data.
Yeah, maybe. Yeah. Let's just do stratified.
Stratified works well. Items are similar within the stratum and tend to differ from one stratum to another. Yeah, I think so.
Okay, and then 6 is why do you think the sampling method described in the questions in steps 4 and 5 will give an accurate representation of the function? Because they're random. I don't know.
They are or number 6.
Well, and especially since we're in different states, there's no way of rigging it.
What's that?
You said since we're in different states, there's no way of like rigging it or
Oh yeah.
more of a spread out area.
We think that it'll be accurate because, like I said, it will be in different states. What we could even do, I don't know how many stores you have around you, but we could go get a couple from Walmart and go get a couple from whatever.
The gas station.
Go get one from the gas station and go get one from.
So we should get one from like different places.
Yeah, we could get a couple from different random places, saying that way it's totally.
Yeah.
I say every other pack. A different.
No. I was gonna say we think the active is in a different state. This will provide a period of states. This will provide unbiased observation based on states. We also collect them from different stores to eliminate the possibility of bias coming from certain stores.
Same source.
Sure. Stores.
So, do I need to, like, sign everyone's name on here?
I think so. She's gonna sign your name, is that okay?
Yeah. I'm okay with it.
Alright, good. I'm confused about what it says in step 15.
And what?
It says each group member sign below that you will not collect data until your project has been approved in writing by your instructor in step 15. What's step 15?
I have no clue. Probably an error. Everything's an error.
Let me see this.
Alright, so that's taken care of. We'll get that submitted. So we ready to go to part 2?
Yes.
That little formulas this one are kind of fun.
Oh yeah.
So for question number 1, says in an October 2008 poll, 684 of 1,006 randomly selected college students reported that they have been involved in an automobile accident in the last 5 years. Use the Wilson's +4 for your estimate and confidence interval below. Find the proportion of those surveyed who have been in an automobile accident in the last 4 years. 5 years, sorry.
And it says use the what?
Wilson's +4.
Oh,
So the 684 plus 2 and the 1006 plus 10.
yeah.
So the p hat should be 0.679.
Okay.
Check your confidence in constructing a confidence interval for this data.
Requirements are that you only have to have as many as 5 or more than 5 sets of data. Okay.
So that's met.
Okay. Determine the margin of error for 95% confidence interval based on these data.
The margin of error equation, this one was.
Weird.
Random.
Yeah. So it's 1.96. Is that 95%?
Let's see.
Yeah,
I
95%.
think so. Yeah.
So 1.96 times.
You guys sound like you're both going to it.
I know, I keep having like a tickle in my throat, but I don't know if it's growing into some, I don't know.
Okay, so 95% is 1.96.
Yeah.
Don't you times the square root of,
Should be 0.0288. 0.028. Yeah.
Did you get that?
Yeah.
Okay. Did you just do the 64 over 1006?
I put in 1.96 times the square root of 0.679 times 1 minus 0.679 divided by 1010. So we're using that plus 4 thingy. We'll see.
Okay.
Construct and interpret the 95% interval for confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. So in Excel, it has it as 0.650 and 0.708. And that's what the answer sheet has, but it has an additional number. So we do it by hand if you want for practice, or we can just go with that.
We can just go with that.
Sounds superb.
How many college students should you survey if you want a 95%?
We gotta interpret first.
Oh, so sorry. Well, we have a 95% confidence interval.
We're
And
95% confident that true population is between those numbers.
way to go.
Yep.
Back to what I was saying. How many college students should you survey if you want a 95% confidence interval with a margin error of no more than 0.015?
This is gonna be fun.
Well, I frankly just don't know.
Okay, so what we have to do is you gotta take 1.96 divided by the confidence interval is what? 0.015, and that's squared.
Okay.
Then you times that by
The P times 1 minus P. Right?
yeah. What's the P value?
Is it 0.6799?
Yeah. 6, 7. And that's times 1 minus 6. I didn't get the right answer. What did you get?
I'm doing it right now. I got 28.437.
I got 3721. 3,721. And the answer is
You're both wrong.
4,269. Why don't you do it? See what you get.
Oh. What? I don't know that.
What are we doing wrong?
I remember it saying that we have to use the normal probability applet to get a z-score.
I don't think we have to because it's a 95%, which is 1.96.
Yeah. Okay.
Sorry, my computer has pop-ups all the time. It's possessed.
It happens. Mine actually, like, the system failed or something, and, like, literally it started screaming at me. Like, it had this high-pitched noise going off. I couldn't get it to stop.
That's annoying.
Yeah, I even, like, had the computer closed, and it was still, like, freaking out at me.
Okay. Plug it in one more time, see what we get. So, 1.96 divided by 0.015 squared times 0.679 that's times 1 minus 0.679.
Okay, now I got 3,721.
That's what I'm getting too.
There's must be one.
That's what we thought out last time, and then Mark's running the test. That's frustrating. I don't know what we're doing wrong.
Maybe. Hmm.
What's the answer they have in there?
1,260.
I just got it.
You did?
But I use the formula above.
You just use the margin of error one?
It says where Z is determined by your confidence level, M is your desired margin of error, and P is an estimate of the true proportion of success. If no prior estimates for P is available, we can use the following formula to compute our sample size. I went 1.96 divided by 2 times 0.015, and everything's squared, and I got 4,268.
Oh, good job. Well, now you are interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. State the known alternative. So
No.
the null would be that equals 60%, and the alternative would be that's greater than 60%.
Yeah.
Correct. Okay.
Isn't the next question like compute the test statistic?
The
Yeah, I
I think that one you have to do in Excel.
Oh yeah.
I think. And Excel gives us 5.174. The answer is 5.173, so it just must be a matter of rounding.
Yeah.
Is there a place in it that has a test with test statistic?
I can see it.
You're supposed to.
I don't remember reading it. But a lot of times. Alright. Determine p-value based on the test statistics. Get your p-value on the normal distribution curve with the test statistic label. The p-value on here is 0.00, so it must be really small.
Yeah. I think on here it says 1.15 times 10 to the negative 7.
How'd they find that?
I have no clue. It doesn't say. Well, it was on a normal probability applet.
Oh, man.
Okay.
Hey, naughty. My dog is like almost chewed through my computer cord.
Really?
Yes. He already chewed through my husband's Apple, well, his Mac one. So he had to get another one. It's like $80.
Holy cow.
Oh, isn't that so small? You're supposed to reject them all.
Yeah, we rejected it way below that.
Okay, and then we'll just say we have sufficient evidence that the people with car accident in the last 5 years is greater than 0.6.
Yeah.
Woo!
Alright. Let's go take the fun test.
Hey, it's a quiz. Ready?
Yeah.
The first question is the symbol. The symbol for the true population proportion isn't that P?
Yeah.
Or is it P?
P without the hat and P without the, what is it called? What's it called?
Period.
A tilde. That's what they're called. Okay. Wait, I'm right, right?
I believe so.
Okay.
So just the P?
I think
Yeah, it's just the P.
So for questions 4 and 5, suppose n equals 20 and p equals 4. So the requirement for constructing a confidence interval is satisfied, and it's true, right?
I think that's true. Okay, and then it says the requirements for conducting a hypothesis test are satisfied.
One of them's false.
I know. I put false for that one, but I don't know if I got them mixed up.
Because I know that n is supposed to be greater than or equal to 5.
That's for the interval. That's for the one today, isn't it?
Yeah.
So the one we read last time, that was an hypothesis, right?
Yeah.
So that one I think would be false because n times p has to be greater than or equal to 10.
Yeah.
And n times p in this one's going to be 5. So that one wouldn't work. I think. So we going with that?
Yeah. Okay. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for the first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 9. Find the P, the plus 4 estimator of the proportion of first-degree murder defendants who are found guilty in this state.
I got 0.734.
I did too.
Cool. Find P hat. The traditional estimator of the proportion of the first-degree murder defendants who are found guilty in this state. Round to 3 decimal places.
Should just be 0.75.
Would you put a 0?
Huh?
Would you put a 0 at the end?
Is that what you think?
Yeah. Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state. There, the verdict is guilty.
Then do we, I remember, do we use, so we use the, okay. Sorry, I just kind of had my little,
That slows it right.
it's alright.
Huh?
Mm-hmm.
Where did you see that? Oh, I was looking in the wrong place.
We got C.
Mm. Mm.
Is that what you get?
Mm. Yeah.
Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
Increase.
Yeah, that's what I was going to say.
Okay. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals half. What is the smallest n can be and both requirements still be met? So n has to be 5.
Yeah, I thought it was 5, but it says the smallest.
This one, I think this kind of gives us the answers. So it confirms 5. Hypothesis is when, is the, at the end of the reading, it talked about n times, and there's in the last reading too, n times p has got to be greater than or equal to 10. And then n times 1 minus p
Yeah.
has got to be greater than or equal to 10. So for this one, we did this one last night too. For 1/2, 20 would work. What about, what's the other thing it has to do? 20 times 1 minus 5. Yeah, it should work. 20 should work.
10.
So if it's anything for this one, so 100. 100 is for 11. That makes sense?
Not really.
So back in the reading,
Mm-hmm.
it's talking about doing a hypothesis test. The conditions for a hypothesis test is that n, the sample, I think that's what it is, n sample, times p has got to be greater than or equal to 10. So for number 10, n times p has got to be greater than or equal to 10. So you plug in 20 for n. 20 times 1/2 is greater than or equal to 10.
Okay.
It's 10. And then the other thing, it has to be 20 times 1 minus P has got to be greater than or equal to 10. So 20 times 1 minus 0.5 is 10 again, so it works.
Okay.
That make sense?
Yeah. No.
Okay, sorry. For questions 12 through 17, use the following information. For the water quality study and the reading, about 60% of macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level of 0.05 with the following hypotheses. Null equals 0.6, alternative is greater than 0.6. They collect new data, and this time n equals 80, x equals 38 indicate good health. The conditions for conducting the hypothesis test are satisfied.
True.
Let me check. Yep.
What is P?
Now p hat is the traditional estimator, right?
Mm-hmm.
So that one should just be 38 divided by 40. Or 80, excuse me.
Yeah.
That's
Point
point 2. Yeah.
And the test.
Z should be negative 2.282.
What?
Yeah.
And then the p-value.
Is it showing on the phone?
The p-value according to Excel is 9.89.
Is it 9?
0.9.
989. What is the decision for this test? Fail to reject the null hypothesis or reject the null? It's fail to reject, isn't it?
Yeah.
I'm going to check that z-score on the applet. What is going on? Oh, hold on a second. What's
You
our...
were right. You were right. It was 988. 9 or 988. So you were around tonight.
Hold on. The alternative is that p is less than 0.6. So... Alright, I think that's right.
Which of the following best summarizes the conclusion of this test? There is sufficient evidence to conclude that water quality in the area has decreased. There is insufficient evidence to conclude that water quality in the area has decreased. There is sufficient evidence to conclude that the water quality in the area has increased. Or there is sufficient evidence to conclude that water quality in the area has increased. I think it's B.
Yeah, I think it's easy.
Walkie-talkie.
All of them are answered?
Mm-hmm.
You always wait till I see it. So I get the bad grade and you fix it.
What's it you mark?
Decrease. So, did you submit it?
Yeah.
Yeah, that was icky.
Well, at least it's not enough.
You are a
stinker.
You just did it.
Okay, so I'll see you guys next week.
Yeah.
Yep.
Okay, thanks guys.
Yeah. Bye.